I want to talk about a couple of topics that come up in the end of the lessons of Code.org's Accelerated Intro. So the first thing is debugging. Now maybe you don't know this, but the original bug in a computer was an actual bug. The computer that it happened in was the size of an entire room, and something was going wrong. The people who were working on this computer couldn't figure out why it was behaving the way it was until one of the scientists working on it discovered a moth stuck in the electronics, and that was the first actual computer bug. And since that day, decades ago, errors in computer programs are still called bugs. So looking at lesson 17, bubble 5 here, I've got a program where I need the farmer to clear this field. And my main advice to you when you got a bug is first, run the program, see if you can understand what the code is doing with the bug. And what I'm seeing here is we've got the stair-step algorithm inside of this loop. And the stair-step algorithm, of course, is move forward, turn left, move forward, turn right. And after the first move, we've got to remove one. So after each step, we're removing one. And the problem is, once I figure that out, right, we're going to repeat this so that it goes 7 times. Once I figure that out, I realize, well, wait a second, not every step has a pile to remove. So maybe I just need an if. If there's a pile, remove it. And let's see if that works. I think that took care of it. Point being, okay, read your own code. Understand what it's doing. Don't just chuck blocks in there and run it and guess. You really have to understand why you fixed it. If you don't understand why you fixed it, then you really shouldn't be moving on. You should hit replay and reread your code to make sure it really makes sense to you. Super duper important. Okay, the quick way in programming is not the easy way. The easy way in programming is working hard to have a deep understanding of what's going on. Next topic, let's take a look at lesson 19, the last lesson in the Accelerated Intro course. This lesson, these bubbles are just some code that they give you that you get to play with. So again, this is an exercise in really trying to read the code and understand what's going on. So let's go ahead and run this one and see what it draws, and isn't that interesting? So again, to try to understand this, we've got a for loop. I've got a counter variable built into my for loop that's going to go from 1 to 200 by 1. And so each time through the loop, I'm just going to move and turn. But the amount of distance that the artist moves depends on what the counter is. So the first time through the loop, the artist is going to move 1 pixel, turn right. Then it'll go back through the loop again. Second time through the loop, it's going to move 2 pixels, then 3 pixels. And that's why we get this nice spiral pattern, because the artist moves a little bit further each time. Well, now we understand what it's doing, but they're asking us to make changes to see what happens. Definitely do that. Play with everything. This is such a useful exercise. What if I start the counter from 20 instead of 1? Took out the middle. That makes sense, because then the first time through the loop, the artist will move 20 pixels instead of 1. That was interesting. If I move this up to 400, then I predict that it's just going to draw more and more squares. Let's see if that works. Prediction was correct. That's nice. What if I count by 5 instead of 1? That would mean that after each turn, the amount that the artist is going to move forward is going to jump up by 5 pixels instead of just 1. Let's see how that looks. Well, that's interesting. It kind of spaces out the lines a little further. I kind of like that. I'm going to try 4 to see if I can get an effect that I like even better. Yeah, that's nice. Other things you can play with. Try it with a single color instead of a different color every time through the loop. Just pick a random color once and stick with that. That's kind of nice. Change the angle. What if I go 89 degrees instead of 90? Now things are getting interesting. Make two changes at once. So you can see that little tiny changes that you make in the code can have a dramatic impact when you're dealing with loops. I encourage you to go even further than this, right? Like throw extra loops in there. The math blocks are fantastic for playtime, right? What if you altered, instead of just moving forward by counter, what if you moved forward by, I don't know, counter, and that caret symbol there is to the power of. So maybe counter to the power of 2. Let's go counter squared. I'm going to go back to 90 degrees here. And I'm going to stick with the random color in the loop again so that I can see after every turn what it's doing. Well, that was interesting. It kind of exploded quickly. What if I go back to something smaller, like 1.1? Not much change there. Kind of surprised about that, to be honest. I expected to see that the spiral would expand a little. 1.3, it's starting to be visible. Not as huge as an effect as I was hoping here. Really what's going on, in case you didn't know, is the spiral starts really tight in the middle and it's getting wider and wider. But anyway, play all throughout these bubbles. And then the last thing I want to talk about is in the project area. Your next assignment after all of this is to create an art project for me. And in the art project area, you get everything in here that was never given to you during the accelerated intro course. So in particular, I really like that in the project area you have the option of setting colors with number values. So in case you didn't know, colors on a computer screen are represented by a mixture of red, green, and blue. These are the primary colors of light. And in a computer, the colors, the values can go from 0 to 255. You can even open up a Google tab and type in color picker. And this is a nice way to demonstrate this. You can noodle around and pick any color and it'll give you the red, green, blue values right on that color picker. So if you find a color that you like, that you want to put into one of your projects, here's how you can get that color into there without having to guess. But the cool thing is, I'm going to reproduce that spiral thing. We had, this time we're using I as our variable, looks like. I'm going to go to the 89 so we have the nice spiral. So 255 in all three, that gives you white. 0 in all three gives you black. 255 red, as you might guess, would give me totally red. If I go like maybe 180, then it'll be a little darker red. You get the idea. Well, you can change these numbers as it goes through the loop, and that's what's really fun about this. Okay, I can, instead of putting a number in there, I can use my variable I, and you see the color changes in a predictable way. You can even add math to alter how fast that happens. So instead of just straight up set red equal to I could go I divided by 2, and then it will change half as fast. If I go I times 2, the color will change twice as fast. And I really strongly encourage you to experiment with this. You can do all sorts of really interesting stuff once you really start exploring color changes in a predictable way. And that's